Hello to all future doctors, hello everyone, hello to all Neet 2026 champions. Hi everyone, how are you all? So before I start this fabulous session of properties of bulk matter, so please let me know everything is fixed, there is no any technical problem. I'm audible to you all and I'm visible to you everyone. Please let me know in chat section. Yes sir, you are audible and you are clearly visible. Please my dear champion. Yes Shiva, we have started the session. Please let me know, am I audible to you all? Am I visible to you all? And this session is going to be game changing for you all, because in today's class we will be covering entire bulk matter. I mean mechanical properties of solid, mechanical properties of fluids and thermal properties of matter. Yes sir, you are audible and you are visible as well. Thank you so much Shiva. Hi Siddhana. Hi Pooja. Hello to all. Hello to everyone. I hope you guys are fit and fine, healthy, and you all are enjoying your lives and you all are close to your NEET exam. So how is the Josh everyone? So Siddhana is asking when you will end the class. Siddhana, what a question. We have just started and you are asking for ending of the class. Okay. Hi Tarun. Okay, so we are going to cover up entire bulk matter, I mean thermal properties of matter, bulk, mechanical properties of solids, in which you have studied about Young's modulus, bulk modulus, shear modulus, stress, strain, and fluid also, Bernoulli's principle, capillaries rise, yes, Stokes law, terminal velocity, everything, and thermal properties of matter also champion, in which you have studied about latent heat, specific heat capacity, Newton's law of cooling, Stephen's law, Boltzmann constant. You have everything, you all know. So this is the right time to execute all those knowledge into do numerical champions questions. So here in this live class, the beauty of this live class is you all can get the PDF of this live lecture. The link will be given in the description. You just need to hit the link and you guys can get the PDF of these questions along with the solution also, right? So this is the base part. Yes. Hi Dikshita, Tarun, everyone. Hi Madhu. Are you all good? How is going on your preparation? This is the last phase for your NEET exam. Okay, so let's begin without wasting a moment. So moving with first question, look at the question. My dear champion, this question is from 2025 question paper, NEET PYQ. Very important question. Who is this? Madhu. Hi Madhu. Hi. Yes Siddhana, this is the quick revision session, because you don't have a lot of time to cover up entire syllabus, all the theory and all. So this is the reason why I have brought up all the quality questions that have been asked by examiner, representative or NTA in previous few years, and all those questions that may appear in this year question paper also. I have brought up all those quality questions. The question will not be exactly same, but the pattern at some extent will be a bit relatable. So these questions are very helpful for you all. So before writing your NEET exam on 3rd of May, I think you all should solve these questions. At least if you are not able to solve, if you are not able to get the answer, you guys can sit keeping your phone or laptop in front of you and with your notebook and just see the solution the way I'm solving the numericals. At least you can see on the screen, and if you required, you can take the screenshot, you can copy the solution also. Okay. Yes. Okay, so move to first question. See my dear champion, I know in this live class there may be variety of student. There may be some student whose doubt is, whose concept is fully clear, and few student might be there whose doubt is not clear yet. They don't know the formula, they don't know how to proceed the numerical. They may having lot of difficulties and challenges in to do the numerical in physics. I know this is common with NEET aspirants, because physics require a bit mathematical calculation, formula and concepts. So along with the solution in detail, the each and every step, I'll be giving you short method also. But This is my responsibility to live up the expectations of each and every student watching the live sessions, right, my dear champion? So have patience and stay connected with this live class till the end. If you are genuinely dedicated to get good rank and good marks in your NEET exam 2026, my dear, you should stay in this live class till the end. Okay, yes, thank you. Is it clear to everyone? So I hope you have now understood the main intention of my live class that I'm giving you here in this. Okay, so let's move first question. So three identical heat conducting rods are connected in series. Okay. As shown in the figure, the rods on the sides have thermal conductivity 2K, while that in the middle has thermal conductivity K. The left end of the combination is maintained at temperature 3T. Okay, this is at temperature 3T, and there are three rods, one rod, two rod, and three rods. All three rods are identical, so means their area and their length are equal. Okay, these three rods are connected in series combination, and look at the question. The rods are thermally insulated outside. Okay, the rod is thermally insulated from outside. It means the heat will only flow in this entire. The heat will not flow in surrounding because it is completely insulated. So if this setup, this rod is fully insulated, it means the rod might be wrapped by plastic and whatever is there. So the rod is fully insulated. It means that the heat loss will not be in the surrounding, in the environment. It means the complete heat will transfer inside the rod itself. So basically here we have to use the heat transfer formula. Okay, I'll be giving you the formula. Have patience. In steady rate, temperature at the left junction is T1. Okay, this junction is having temperature T1, and then this junction is having temperature T2. Okay, T2, the ratio of T1 by T2 will be what? So this is the question. A good question, simple. Yes, which option will be correct according to you all? Tell me. Tajuddin, hi Tajuddin. Tajuddin is saying option number C will be correct answer. Let's see. So basically, in this question, we have to use heat transfer formula. If you know the heat transfer formula, then only you can solve the question. There is no any shortcut. This question is based on formula. If you have formula, you can get the answer. If you don't have formula, you cannot get the answer. Simple. So let's apply heat transfer formula because heat is transferring inside the rod. Okay, so let me use here yellow color. Okay, let's say red color. I think red color is visible to you all, everyone, champion, please. Okay, so do you know, my champion, heat transfer formula? I hope you all know the heat transfer formula, a very quality formula. Hi, Addy is writing Ka delta T by L. Yeah, of course, KD is right, I think, at some extent. Very good, KD. But AD, sorry, not KD, AD Chauhan. But which option will be correct here? Come on. Yeah, AD, you are correct. Which option will be correct now? If you know the formula, you can solve the question, entire question as well. Yes, my dear champion. So basically, the heat transfer formula is equal to Ka delta T by L. This is the formula. Ka delta T by L is the formula. K is the heat constant, A is the area, which is similar. All the rods are similar. Area, this is area here, this area. If the rod may be like cylindrical, so the area will be circular, cross-sectional area. And delta T is the difference in temperature. So we can also write this formula as Ka, we can write T higher temperature minus T lower divided by L. L is the difference between length of this. So if we apply this formula here between these two, because here at this spot the temperature is 3T and this is T1. So if we apply, and this junction is between these two. So if we apply this formula here in this way, so what will be the result? This is 2K. If we apply here 2K, so this is 2K A, and in this junction, this is the higher temperature, so we can write here 3T minus T1 divided by L, and which will be equal to, because the heat is steadily flow, and now here the heat will transfer to here. So this junction, both will be at the same temperature, same heat will be transferred. So we can write here K A, and in T1 and T2 here, this is T1 and T2, T1 and T2, this will be temperature of T1 is greater than T2, so T1 minus T2 divided by L. Let's solve this. So basically, my champion, can you see here A and L, because here three identical heat conducting rods are there. It means the area will be same and the length will be same. So Ka, L cancel. If we solve this, so this will be 3 to 6T minus 2T1 is equal to T1 minus T2. So can we find out here 6T will be 2T1 will go there. So this will become 3T1 minus T2. Let's say call this equation number 1. Now similarly, if we apply heat transfer here at this position, because here is the temperature difference, and at this position here is the temperature difference. So if we apply the heat transfer formula again here, this position and this position, so what will be the result? Now can you see the heat is transferring here this way? So this will be Ka T, this is T1, T1 is the higher temperature, T1 minus T2 divided by L, and that will be equal to, now in T1 and T2, this is the, here this K is the thermal conductivity, so we are taking K here. Now if we talk about T2 and T, so this will be the thermal conductivity, so we can take here 2K, A will be there, and here this and this will be the higher temperature, so T2 minus this is T, that will be divided by L. Again Ka common, L common, cancel here. So if we solve here T1 minus T2, that will be equal to 2T2 minus 2T only. Now solve this. So 2T2 will come this side. So 2T, T1 is already there, T2 is already there. So this will become 3T2 is equal to here minus 2T. So minus 2T will come this side, or we can do one thing also here, my dear champion. If we can do one thing, so just make the solution easier. Instead of making this solution very complex, we can make this easier. So 2T will come this side, and this whole family will go there. So it will become 3T2 minus T1. Now champion, can you see here, this is 6T is equal to this, and this is 2T is equal to this, my champion. So if we subtract equation 2 from equation 1 by multiplying equation 2 from 3, so it will become 6T, and this is already 6T. So we can do one thing, we can multiply by 3 here in this whole equation, and we can subtract from this to this equation. So what will be the result? 6T will be equal to 3T 1 minus, and this will become 6T is equal to, this is 3 we are multiplying 3 here, so this will become here, this 3 is 9T2, and this will become 3T1. So we can write here 3T1, and this is equal to here minus 3T1, this is minus 3T1, and this is equal to 3T2, so this is equal to plus 3T2. Now subtracting this, so on subtracting, sign will change here, so this will be cancelled here, 3T1, this will become 6T1, and here minus T2, and minus this will become minus 4T2, but we require T1 by T2. Now we can find out T1 by T2, so we can write this as 6T1 is equal to 4T2, so T1 divided by T2 will be equal to 4 by 6. This will be 2 2 ja and 3 2 ja. 2:3 is the correct answer. Any option is there? So we require T1 by T2. So T1 is 60, I think some 336 T1, T2 minus 4T2, and this is 6T1 minus 4T1, so this is equal to 4T2. What we required T1 by T2, so this will be 3T1, 4T1, 6T1, 3T2, and 2 2 4, so 2T2, 3T1. Yeah, check it once. Any problem is there? Which option is correct? Come on, champion. So short trick for KCET. I'll be giving you short trick also. Check it once. Which option will be correct? Check it once, guys. I'm waiting for your response. 5 by 3 will be the answer here. Yes, which option will be correct, champions? Please look at the solution. T2 minus T1, T2 minus T1. This is T2 minus T. Yes, champion. Which option will be? C is correct. Sir, we are not preparing. Sir, 92 in second equation. I think, yeah. 92 in second equation, exactly. Exactly. That was the silly mistake here. So, see, one silly mistake can lead deduction in marks. You are correct. We are multiplying with 3 here. So, 360 we are writing correct, but here, 3 3s are 9. And we have written here, this is, wow, my God. So, just because of one mathematical mistake, marks may be deducted there. So I think yes, correct. So this was the mistake here. That's why the answer is not matching, because I know we have already solved this question so many times. So I know the answer is 5/3 here. So let's solve this question. Yeah, so by multiplying this 3, so this is minus 3t1, okay, minus 3t1, and 3 3s are 9, so this will be 9t2. Okay, now subtract this and this is plus. Okay, this, it has already become 0, and 3t1 plus 3t1, this is equal to 6t1, and this is minus 9, and this minus 10t2. So this is equal to 6t1 is equal to 10t2 minus t1 by t2 will be 3 2 ja 6 and 5 2 ja 10. So this will be t2 will go there, 5 divided by 3. Any option is there? Any option? The option number A will be correct. Yeah, option number. Bhumi. Bhumi is correct. Shiva, sir, T1 is 6 and T2 is 4. We have to find out the ratio, Shiva. We don't require to find out T1 and T2 separately. We have just to find out the ratio. Bhuvan is correct. Bhumi A is correct. Dikshita is correct here. So you guys, you have just witnessed now one silly mistake, one mathematical calculation, you may stick there and the confidence will suddenly low down. So whenever you are solving the numerical, physics numerical, make sure to stay connected with the solution, your mathematical calculation. Yeah. Hasina, hi sir, how are you? Thank you so much, Hasina, for asking. I'm absolutely fine. Yes. This is very important for Neet point of view. Please, my dear champion, this is very important for Neet point of view. Let me tell you again. So here in this question, look, champion, this is this, and this is a first rod, this is second rod, and this is the third rod. How many rods are there? 3 identical rods, right? And this rod is having temperature 3T, and the end of this rod is having temperature T. So if this is 3T and this is 3, so this is absolutely clear, na? The heat will transfer from here to here. Heat transfer from higher to lower concentration, you know. So if this is having higher temperature, so heat will transfer from this to this. And if the heat is transferring from this to this, it means it is at higher temperature comparatively to this, and it is at higher temperature comparatively to this, and it is the higher temperature comparatively to this. Simple. And we have just applied the formula, this formula. Here in this formula, TH is equal to T higher and minus T lower. So when the heat transfer between two positions, two spots, we generally use this formula. I hope this is clear to you all. I hope everyone this is clear to you all. KCET students, let me tell you one very important thing. Honestly, my dear champion, if you are appearing in KCET exam, I think it is just after 2 days, on 23rd of April. My dear champion, these are very important, and especially this formula for KCET is also very important. When the heat transfers takes place. Sure, Bhumi. At the end of this live class, when we'll be done with this live class, solving all the questions, at the end of this live session, I'll be talking with you all KCET aspirants. Don't worry. I'll be giving you here tips and tricks to score good marks, to ensure to get good rank and good marks in your exam, my dear champion. So stay connected and stay here till the end of the live class. Okay, Bhumi, Tarun, everyone. So are you all enjoying the session? If you all are enjoying the session, please show me your involvement, show me your presence, send me some hearts, send me your thumbs up, and stay here in this live class. I hope this question is clear to you all. Please tell me, is it clear? Any doubt to anyone? If anyone is having any kind of doubt, I can repeat the solution again and again for you all. And the student who joined this class for the first time, who came up here in the very first time in the live class, go and hit the like button and share this live session with your friends as well. so that they may avail advantage, they may get advantage from this live class basically. And this live class is exclusively very important for both the aspirants, for KCET students and as well as NEET aspirants. So my dear champion, hit the like button. Please go do this first. Hit the like button. I can see only 10 likes are there, almost. And lot of students are watching the live class. At least you guys can do this small thing for me. Go and hit the like button. This is just for you. Hi Shiva. Thank you Bhumi. Yes sir. Okay, moving to next question. Okay, very important and good question. So this question is the bulk modulus. If you just hear the word bulk modulus, so it indicates this question is from mechanical properties of solid basically, because bulk modulus of spherical object, and we are pushing that object uniform pressure. And so what will be the frictional decrease in radius? Very easy question. Yeah sir, clear. Sana is saying yeah sir, clear. Very good. I hope you have pressed the like button also, everyone. Done sir. Madhupriya, thank you Madhu for giving your kind thumbs up here. Tarun is writing option number C. Okay, Tarun looks very confident here. Yes sir, option C is correct. Shiva is saying option C. Okay, just the student who all are responding here option C, just wait a little while. I'm just looking forward to get the response from other students. Lot of students are watching the session, and this is very important question. This is from NEET 2017. So you guys cannot ignore this question, and you should not actually. Okay, Dikshita is writing option C. Okay, very good. Okay, look at the question. The bulk modulus of a spherical object is B. Okay, if it is subjected to uniform pressure, the frictional decrease in radius will be what? So basically here the question is, there is a sphere and this sphere is having radius r already. So this is the original shape of sphere before pressing by uniform pressure of P. This is the initial situation. After pressing this sphere, let's say the sphere will look like this way. Now the sphere has reshaped in this form, and the radius will be, of course, if the earlier shape was larger, and this now by applying the subjecting the uniform pressure, the shape has changed and the shape has become smaller. It means the radius has decreased, and we have to find out the frictional decrease in radius. Do you know, my dear champion, what is this called? Frictional decrease in radius. Listen here. So initial radius was r, and this is the final radius. This is initial radius was Ri, and the final radius is Rf. So how much is a decrement in the radius? So that will be R final minus R initial. This is called difference in the radius. Now what does it mean by frictional decrease? So my dear champion, the frictional decrease in anything, frictional decrease in radius we are talking about here, frictional decrease in radius. So frictional decrease in radius will be the decrement in the radius divided by original radius. So we have to find out here this delta R by R. The frictional decrease in radius, we have to calculate this value here. This is the question here. Are you getting my point? Delta R by R. Is it clear to all? Yes. Sir, option C correct. Yes sir, very good. Okay, Mr. Raju, hi Raju. Raju has arrived. Very good, Raju. Okay, lot of students are saying option C. Let's just wait. Okay, now the bulk modulus of spherical object is B. Do you know, my dear champion, when we talk about any spherical body, I mean the volume. If a spherical body is there, we are going to give priority to volume. So volumetric change will be there, and that is the reason why we are talking about here bulk modulus, right? Which is called bulk volumetric modulus as well. So there is very important formula. You all know the formula. If we talk about the bulk modulus, so bulk modulus, which is equal to capital B in this question will be equal to stress by strain. This is the formula of Young's modulus. Length, the changing will be in the length, whether the elongation or expansion or compression will be there. So that is Young's modulus. When we talk about change in length, when the volume is changing, we'll be talking about bulk modulus, right? When the shape is changing, we talk about shear modulus, right? So here this is bulk modulus, stress by stress, and stress is what? Stress is pressure, which is given to you here. So we can write here B is equal to P by change in volume. the ratio in change in volume. So delta V divided by V, and we all know if this has been pressed, this sphere has been pressed, if this is pressed, so basically bulk modulus, the change in ratio, the change in volume, the decrement in volume is taken as negative because the volume is decreasing gradually. So we can write here this B is equal to P into V divided by delta V. I hope this is clear to you. We can put negative sign, otherwise we can ignore negative sign as well. Okay, now moving to next part. Okay, now do you know, my champion, if this sphere is here of radius r, so V is equal to 1 by this V. If we talk about volume of sphere, so do you know the formula for volume of a sphere, which is equal to 4 by 3 pi r cube? I hope you all know the mathematical geometrical formula for sphere. Why I am taking the volume? Because we require delta r, and there is no way to find out the delta r except differentiation. So V is equal to 4 by 3 pi r cube, and if we differentiate with respect to r here, so dV by dr will be equal to 4 by 3 common, pi common, and r square. This r square can be written as what, my dear champion? 2r. I hope this is clear to you, because r square will be equal to 2r. We are differentiating here, so this will be equal to 2r, right champion? This will be equal to 2r. Why we are doing this? Because our intention is to find out here dr and dv we want to find out. So dv by dr will be equal to 4 by 3 into 2 pi r. So dv here can be written as 4 by 3 into pi into 2r into dr, right? This is V and this is dV, this is V and this is dV. So if we divide equation number 1 by equation number 2, so V by dV will be equal to, V is already 4 by 3 pi r square divided by 4 by 3 pi into 2r into dr. I hope this is clear to you all. So 4 by 3 pi cancel here, and this r is also cancelled here, and this is 4 by 3 pi r cube, my champion. So this will be equal to, this is a square here, so yeah, this is the r cube. So r cube will be here, this is 3r square, this is also 3r square, this is also 3r square. Let's take, okay, so here is 4 by 3 pi r cube, 4 by 3 pi r cube, and this is 4 by 3 pi r cancel, and this r square will be cancelled by r. So we got a result here, V by dV is equal to what? R, and here this is 3 into dr. Oh my god, can you see here, this is dr. If we change this, dv by dv is equal to 3 dr by r, and this dr by r is the decrement, fractional decrement in the radius. So dr by r can be written as 3 will go there, so dv by 3v. So we want dv by 3v, and which is equal to dv by 3v. We can find out from here. So this will be B by P is equal to dV, and we require dV by here. This is dV by B. So what will be dV by B? So this will be dV by B will be equal to P by B. Now we can put here this here. So dr by r is equal to d by dv. D by dv will be replaced by P by B. So this is equal to P by B, and 3 is already there. So P by 3B is the correct answer. P by 3B. Any option is there? Yes, option number C will be the correct. This is the answer. We can ignore minus sign. Yes, you guys, all the KCET students, all the KCET aspirants who are about to write their KCET exam on 23rd, just after 2 days. Yes, my dear champion, you all can stay here in this live class. This will be very important and very beneficial for you all. If you see all these questions, if you are not solving, my dear champion, you all can see the solution, at least how I am solving the question. And this question is basically very important for NEET exam, because I have brought up these questions as PYQ. These are the PYQ question. Is it clear to all champions, everyone? Mallappa is giving option number C. Tanji, Shiva is correct here again. Anu, okay, hi Anu. Sir, this is too much lengthy. See, my dear champion, you can make this solution very easy. If you solve such question 2, 3, 5, 10 questions based on just only one concept, your speed automatically will increase. How? Let me give you a short example. Bhumi, please watch here. So, how you can solve this question, Bhumi? Listen, why I have given you here the detailed solution? Because this is the final phase revision. If I go through the shortcut, and if you may stuck somewhere, so your motivation will down. So that is the reason why I'm giving you the solution in very clear manner, right? By the way, you guys can solve this very easily. How? You don't require to draw the diagram and all. If you are topper, if you are ultra pro, look, the bulk modulus of spherical object is B. So you can directly write, na, the bulk modulus B, which will be equal to pressure, which is stress, and change in volume, delta V by B. Right? This is clear to you? Say this equation number 1, right? Now the question is find out the fractional change in radius. So fractional change in radius means dr by r. Now the important question is here, how you can get dr? You cannot get dr directly. There is only method to find out the dr is differentiation. This is the only way how you can get the dr. So the solution will be a bit lengthy, but you can follow the shortcut method also, because you all know the formula for the volume of a sphere in mind. So if you know the formula for volume, if you are topper, so you can directly write dV by dr will be equal to 4 by 3 pi RQ will be differentiated. So this will be 3 R square, right? So this is dV by, so dV is equal to 4 by 3 pi into 3 r square, and dr will be multiplied over there, right? Now divide by, if you divide this by v, if you divide this by v, which is equal to 4 by 3 pi r cube. Now the 4 by 3 pi, 4 by 3 cancel here, r square r will be cancel here, right? So dv by d will be equal to 3 dr by r. 3 dr by r. Look at the solution. Now you can put this value. Now you can put this value here. So if you put this value here, b will be equal to p by, and delta v by v, which is equal to 3 dr by r, 3 dr by r, and you require dr. So dr by dr will go there, and b will come here. So dr by r will be equal to p by 3b. Look, my champion, this is the answer. I can solve this question in very simple manner as well, but my intention is to give you clarity. There are different variety of student may be there in this live session. Some student whose doubt is fully clear, and some student will be moderate, who all are still facing challenges in to solve the physics numerical. And that is the why I am using this method, so that I can provide you clear approach how to solve the numerical in physics. I hope this is clear to you, Bhumi. Look, we got the answer. We got the answer, P by 3B. I hope, Bhumi, this is clear to you all. So this live session is dedicated to all the students, average student, below average student, moderate student, topper student, super topper student, for everyone. Yes, Anu, yes, just good, you score 100 in physics. Clear to everyone? You all are enjoying the session, everyone? Yes. Okay. If you all are genuinely enjoying the session, please write in chat section, yes sir, we are enjoying the session, and we have pressed the like button also. And if you have not pressed the like button yet, go and hit the like button first. Okay, thank you so much. Moving to next question. And generally the paper of the year 2016 was so lengthy and tough as per the students, if I go through past few years of question paper, the standard, the year of 2017 and 16, I got 98%, sir. Bhumi, very good. You are in the race of 13 and 40 lakh student, those who all are going to appear in Neet exam this year. If you are Neet aspirants, and if you are KCET aspirants, still there is lot of competition in KCET to get the good rank college, a reputed college and prestigious institution of Karnataka. So I think you are in the race. Very good. Dikshita, thank you. Shiva, thank you. Okay, moving to the next question. Wow. From Neet 2016. A rectangular film of liquid is extended from, 4 centimeter by 2 centimeter to this. Okay, so there is a rectangular sheet. What will happen? If sheet is there, it means which what type of changes will be there? There will be area changes. Because sheet is there, it means length into breadth will be there. So area, the entire area will change. You are from, thank you so much. Bhumi is saying, sir, where are you from? Okay, I'll be revealing this, where exactly come from. Just wait a little while. I'll be answering this question here. Okay. So my champion, basically there is a rectangular film of liquid. So rectangular film of liquid. So there will be area expansion. So change in area. What will be the change in area? Change in area. Final area is what? 40 into 20. That will be 20 centimeter square. Minus initial area 4 centimeter by 2 centimeter. So this is 12 centimeter. So the change in area is, my dear champion, 12 centimeter square. But a very important concept here, we are talking about rectangular film. Can you see here, rectangular film? So in rectangular film of any liquid, so there are two surfaces. Do you know? There are two layers. So the area increment will occur in both the layers, upper layer and the lower layer. So the change in area, the final change in area, or we can also say extension in area, will be equal to 2 into 12. I hope you all have understood the concept here, because we are talking about film of liquid. So there will be two thin film of the liquid. So area extension will occur in both upper film and the lower film, right? Now, okay. If work done is 3 into 10 to power minus 4 joule, very good. So work done is equal to 3 into 10 to power minus 4 joule, perfect. Then what will be the surface tension of the liquid? So this question is not at all KCET level and any level. This is very easy question, I can say board level, but this question was asked in previous 2016. So you know, my dear champion, work done, the formula for work done is equal to, I hope you all know, surface tension. When we talk about mechanical properties of fluids, so it comes in that chapter, surface tension into change in area. This is the formula. Please, my dear all NEET aspirants, please keep this formula in mind. This is the formula of work done. When a thin film is, expand or contract, or any soft bubble is expand or contract, so we generally use this formula. Work done into change in area, right? So work done is given here 3 into 10 to power minus 4. Surface tension we don't know. We have to find out here. Surface tension we don't know. We have to find out this. And change in area will be 24. I know most of the lot of student will be putting here 12, which will be incorrect, because this is all about thin film. So this will be 24. So surface tension ST will be equal to 3 into 10 to power minus 4 divided by 24. And one very important thing, these all are in centimeter. If these all are in centimeter, so we have to convert in meter square first. Why? Because this is also in SI form, so we have to convert into meter square. So do you know, my dear champion, when we convert centimeter square into meter square, we multiply 10 to power minus 4. 10 to power minus 4. Always keep it in mind. 10 to power minus 2 whole square is equal to 10 to power minus 4. So this will be 10 to power minus 4, which is cancelled here. So ST will be equal to 3 will cancel this. So this is 1 by 8. If we divide 1 by 8, 1 division, so 0.0, 8 1 ja 8, 2 0, 8 2 ja 16, 2 0, 8 5 ja 0.125, 0.125, and this is surface tension. Here is work done, so this is joule, and this is area, so this is meter square. We can say per meter also, because we are finding out here direct surface tension, so we can Newton per meter. So this is 0.125 Newton per meter. Answer, any option is there? Yeah, option number B will be correct. Yes, is it clear to all, champion? Sir, option B. Wow, Shiva is correct, Bhumi is correct here. Dikshita, which option you responded? Okay. Sir, C. Sir, can I know your name? Yeah, sure. I can tell you guys my name. Sir name is Sonu. Shiva know my name. Actually, Shiva is very consistent in my classes. So my dear all students who have joined this session for the first time. So my dear champion, my name is Sonu. I'm your physics faculty for all prestigious examination, all like Neet, KCET and your JEE as well. So surname is Sonu. Okay, so my name is Sonu. You all can. So when you sir double S, right? S square. Okay. Moving to. I hope this is clear to all. Any problem to anyone? This question is important for KCET. Why I'm telling you? See, comparatively to NEET, in KCET generally formula based question comes up. Most of the questions comes direct formula, direct approach, and this is very common formula, very important formula from mechanical properties of fluid, the chapter you have studied about Bernoulli principle, equation of continuity, right, and all, capillary rise, surface tension, surface energy, thin film and SOP. So this formula is very common and most asked formula. So this is important for KCET also. Okay, Ambriya, is it clear to you? Is it clear? I hope you got the answer. If you got the answer, if you are satisfied, give me thumbs up. Okay, should we move ahead to the next question? So please keep it in mind. So let me tell you how you guys can memorize, remember this formula. Listen, if I ask you in mechanics, what is the formula for work done? Work done is equal to force into displacement, which is dx. I hope you know the formula. So this formula is a bit related to this formula here. Here in mechanical properties of fluid or solid, the body changes their shape and due to force. But here in this chapter, generally we use the term surface tension for the force. Surface tension. So basically, force has replaced by surface tension. And in mechanics, the body displaces by some distance, 2 meter, 3 meter, when we push object, when we pull the object. So at the place of displacement, we are taking change in area, change in volume, whatever. So this formula and this formula, I think both are, a bit having analogous relation with each other. But how the toppers, memorize these formula by making the relation between the formula from each other in physics. This is nothing new. If you are considering this formula new, so this is not new, right? So this is just related to this one. But how you are remembering, how you are memorizing the formula, it matters in physics. Okay? Yes, sir. Thank you, Tarun. Hi, Sanjana. Hi. Hi, Dikshita. Hi, Shiva. Is it clear to all? Moving to the next question. Oh my God, this question has been asked by, twice. NEET 2016 and 1999. So this question has repeated twice. It's very easy question. I have already solved this question so many times. I don't answer without solving the question again. I am attending by. Okay, you are writing your JEE exam, GEE, that is JEE, I think, Malappa. Yeah. Okay. So JEE exam, I think it's over, no? Both the exams. First was in December and the second was in April. Okay. Okay. Yes, which option will be correct? Please don't rush and don't be in such hurry to get the correct answer. You cannot get the answer of physics numerical in very short way. You have to look at the question. You will have to read the question very calmly. So first read the question, and then if you don't want to solve the question mathematically, you can use your smart logic to get you can guess. And I have already uploaded a video how to guess the MCQ question in NEET exam. This is not good, but when all the doors has been closed, there is no way. You're not getting answer. You have stuck somewhere, but you want to fill the bubble. So you guys can also move to guessing the MCQ correct answer, but not random. Come on, because you all know the NEET getting the correct answer will lead you +4 marks, and marking the wrong option, bubbling the wrong bubble, -1 will be deducted over there. So negative marking is there. So whenever you are bubbling the OMR sheet, please make sure you should have patience, smart approach, clarity and everything. Okay, solve this question everyone. From NEET 2016 and 1999. Yes, sir. Shiva is saying option B is correct. Okay, okay. Let's solve the question. Okay, the coefficient of linear expansion of brass and steel rods are alpha 1 and alpha 2. Okay, lengths of brass and steel rods are L1 and L2 respectively. So L1 and L2 is the initial length before elongation, before expansion. These two are the initial length, their respective initial length, original length. Okay, if L2 minus L1 is maintained, it means that the change in their length, is always constant. It means maintained same at all temperature. Which of the following relations holds good? Okay, see my dear champion, so there are two rods and this L1 and L2 is the original length before expansion. Okay, so my dear champion, if I write here, do you know the relation LT, it means L at any temperature T is equal to L naught 1 plus alpha delta T. I hope you all know this formula. This is called linear expansion in solids. Linear expansion in solids, right? This is, or we can also write, we can remove here T as well, because this is the new length that we are getting, new length after expansion. So L is equal to L naught plus 1 plus alpha delta T. This is the formula of linear expansion. Now apply this formula on both rods. So if we apply this formula on both the rods, so what will be the, so let's apply this formula on first rod. On first rod. So if we apply this formula on first rod, so L, let's say I'm taking here L, the new length of first rod, will be equal to original length of first rod is L1. So this is L1, 1 plus, what is the linear expansion? Coefficient of linear expansion, alpha is there. Okay, so this is alpha 1, and at all the temperature, it means equal temperature is applying on both the rods. So this is delta T. This is delta T. Let's say call this equation number 1, right? Now can you see here, if L2 minus L1, perfect. Now if we take here L is equal to for second rod, I'm writing this equation, this for the second rod, so what will be the result here? So L can be written as L2, because L2 was the original length for the second rod, okay, before expansion. So L2 into 1 plus L2, this is L2 plus, this is alpha 2 and delta T, same temperature, this is second. But here both has become equal to each other. This is not correct. So we can say L1 dash and this is L2 dash. Now if we subtract both the equations, so L1 dash minus L2 dash will be equal to here this will be L1 and this is minus L2, L1 minus L2, and now we can take here common. So this is alpha 1 delta T, so this will become L1 alpha 1 delta T plus this is L2 alpha 2 delta 2. Now my dear champion, this is L2 dash minus, this is the L1 dash minus L2 dash, this is L1 minus L2, and the question is saying that both L2 minus L1 is maintained. So if L2 minus L1 is maintained, we guys can subtract L2 minus L1 as the question is required. So let's subtract equation 1 from 2. So if we subtract equation 1 from 2, this will become L2 dash minus L1 dash, right? And we can open the bracket here. So this is L2 plus L2 alpha 2 delta T, and minus, we are subtracting this. So this is L1 and minus L1 into alpha delta T, and this is here alpha 1 and this is alpha 2. My champion, here this is L2 dash minus L1 dash and this is L2 minus L1. L2 minus L1. Here can we take common? Delta T will common, and this is L2 alpha 2 minus L1 alpha 1. But the question is saying the difference in their length is maintained at every temperature. So after expansion, again the difference in their final length will be equal. So this and this both are equal. So this will be cancelled here. And delta T will also go here. So we are getting L1 alpha 1 is equal to L2 alpha 2. This is the answer. L2 alpha 2. This is the answer. I hope you have understood the concept. Let me write it again using another color. So L1 alpha 1 is equal to L1 alpha 2. This is the answer. You can mention in bracket here because L2 dash minus L1 dash is equal to L2 minus L1 as per the question. So we have cancelled these two terms. So L1 alpha 1 is equal to L2 alpha 2. Which option will be correct here? L1 alpha 1. This is L1 alpha 1. L1 alpha 1 L2. This option number B will be correct. I hope you have understood the question here. Okay. Hi Sharan. Hello to all. Sir, can you explain me second question? Second question again. Sir, in KCET negative marks is there. Sir, speed up or give break, sir, please. Arif is attending the class. Arif is a bit late. Don't worry, Arif. We have just done only 4 questions. Still, a lot of questions are remaining. Sir, lunch break. You guys want lunch break? I hope. Vara Lakshmi is saying, sir, question number 2. Can you please explain question number 2? Guys, you are asking for question number 2. Where is question number 2? This question, you guys are asking this question? Are you asking this question? Yes, Vara? Okay, I'll be explaining this question after completion of 10th question at least. After 10th question, I will be explaining this question again. Otherwise, don't worry about this question. I'll be giving you the solution again. Stay connected with this question that we are solving here so that the rhythm would not break here. So stay. Now, we have solved this question here, question number 4. Don't worry, all the students who all are asking for question number 2 explanation, I'll be giving you the explanation for that question. You don't need to worry about that. Okay, maintain this momentum. Okay, so question number 4, is it clear to everyone? Did you understand the concept of linear expansion? Yes, sir. Sir, Insta ID. Okay, I'll be sharing my Insta ID as well with you. Don't worry, you all deserve it. Okay, so moving to the next question, question number 5. Okay. The maximum elongation of a steel wire of 1 meter length if the elastic limit of steel and its Young's modulus respectively are. Okay, so this is Young's modulus, and if the elastic limit means delta L. This is the delta L, and we are talking about wire here. Wire, so it means which expansion will be this? Linear expansion, because length is increasing. So this is linear expansion. So when will you say? You may say, sir, but okay, I will be sharing my Insta ID with you all champions. Okay, the student who have not pressed the like button, go and hit the like button, everyone, and share this live session with your friends as well. If you are having a good friend who deserve it, otherwise you should not. Okay, so let's do the question here. So look at the solution basically. My dear champion, if you can see here in this question, there is very important term Young's modulus. And do you know Young's modulus? When Young's modulus comes up, when we talk about linear expansion. So the formula for the Young's modulus is equal to stress divided by strain. This is the formula for Young's modulus. And stress means what, my dear champion? Stress means what? Force by area. Force divided by area. And strain is what, my dear? The ratio of change in length divided by original length. This is the formula. This is the formula for Young's modulus. Now look at the question. The maximum elongation of wire. So we have to find out delta L here. And okay. Elongation of the wire 1 meter. So L is given here, everything is given here, nothing challenging. And can you see here, unit, this is not delta L, this is a stress, because Newton per meter square. And do you know Newton per meter square means what? Force divided by area. Newton per meter square. It means that this is nothing, this is force per unit area. It means that this is a stress. Stress is directly given to you here, 2 into 10 to power 11. Why? Because Newton per meter square unit. So you can also go through units as well, my dear champion, right? Okay, so just apply the formula here. So Young's modulus is equal to force by area, which is equal to 2 into 11, 2 into 11, 2 into 10 to power 11, and this length will go there, length divided by delta L, we don't know. So now apply final values. So this is here, y is the Young's modulus, which is equal to this, 8 into 10 to power 8 is equal to, this is 2 into 10 to power 11 into L. L is the 1 meter here, so 1 divided by delta L. So delta L will be equal to 2 into 10 to power 11 divided by 8 into 10 to power 8. So can we please solve this? So 10 to power 8, 10 to, this will be 10 to power 3 here, and this is delta L, this is 2 by, so this is 1 by 4 into 10 to power 3. So if we solve this 1 by 4, so what will be 1 by 4? 1 by 4, can you see, my dear champion? So we can also write this is 4 into 10 to power minus 3. If you can see, this is 1 by 4, so we can write this as 1 by 4. Solve it. I think solving is the good thing here. So if we solve here, so 4 and 1, this will be 0.45, the 20, 0.25, right? So which option coming here? 1 meter Young's modulus is equal to 8 into 10 to power 8. Where is stress into length? Delta L will be there. So delta L will come as any values are correct, na? 2 into 10 to power 11 divided by 8. So 2 4 ja 8, and this will go there. So 1 by 4, 0.25, and this is 1 by 4, it means 0.25. So 4 into, yeah, 4 into, I think 4 mm is correct answer. Which option? Yes. Exactly correct. 4 mm will be the correct, because this is 1 by 4 and this is 10 to power 3. So you all know 1 millimeter is equal to 10 to power minus 3. Yes, Bhumi is correct here. Option A will be correct. Yes. Everyone, please, everyone respond here. Whatever you are getting answer, please respond. Please show me what is your answer here. Speed up. Why, Bhumi? I see, I have already shared with you, I cannot speed up more. Okay. Yes, Bhumi is there. Bhumi, wait, sister. Start poll. Yeah, good idea. Hi, Shiva. Yes, Arif. A, sir. Very good. Very good. Yes. Hello everyone. Yeah, Shridhara. Hi Shridhara. Yes, moving to the next question. I hope this is clear to all, everyone. So I hope you all have understood the question here. This was the question here. So basically here, this was the Young's modulus. Actually, why this answer is changed here? Because do you know, my dear champion, if this is Young's modulus, so where is the Young's modulus? Where is the Young's modulus? length if the elastic limit of steel and its Young's modulus. So basically this is the Young's modulus here. This is the Young's modulus. We have changed the values. So actually this will come here. That is the why the answer is changing. Otherwise 4 mm is the correct answer. So this is Young's modulus here. Young's modulus, we have changed the place of the values. Values are correct, we have used, but we have changed the place of the values. So basically here, in this question, stress is this first one. This is the stress, because respectively we have ignored respectively term here. So this is the stress because elastic limit, and this is Young's modulus. So this is Young's modulus, 2 into 10 to power 11, right? So by putting the values, so now we can put the values here. This value, this will come as this is 8 into that is the reason why 1 by 4 is coming there, 10 to power 8. Right, so Young's modulus is 2 into 10 to power 11 is equal to 8 into 10 to power 8 into length is 1 meter divided by delta L. So delta L is equal to 8 into 10 to power 8 divided by 2 into 10 to power 11. Now can you see the answer here? This and this is 10 to power 3. So 10 to power 3 will go there. So delta L will be equal to 4 into 10 to power minus 3 meter, and which can be written as 4 mm. This is the answer. Is it clear to all? So just due to changing the exact position of the values, the answer has also changed. So always make sure to focus on respectively term, very important term, because sometimes it may lead deduction in marks, my dear champion. Lunch break, you want lunch break very quickly. It just been, I think, 1 hour only. It has just been only 1 hour. You guys are asking for? Champion A is correct. Yes, Bhumi, you are correct. Shazia Sultan is asking for shortcut. Yes, shortcut. Shortcut. What do you want shortcut other than this, my dear champion? If the formula of Young's modulus, look, let me give you again here. This, my dear champion, if this is Young's modulus question, so Young's modulus means what, my dear champion? Stress by strain. So we cannot make shortcut other than this. There is no any shortcut. This is the direct formula. What you want shortcut in this? So here Young's modulus, stress is given to you here in this question. Stress here is stress. Okay, so which is 8 into 10 to power 8, and this is a strain which is equal to delta L by L, so L will go there. Now Young's modulus, here is Young's modulus, 2 into 10 to power 11, so it will come this into is equal to 8 into 10 to power 8, and L is equal to 1 meter divided by delta L. So we want to calculate delta L, so delta L will be equal to 8 into 10 to power 8 divided by 2 to power 11. So this is 2 4 ja, and this is 10 to power 3, so delta L can be written as 4 into 10 to power minus 3 meter, and if this is minus 10 to power minus 3 meter, so this will be equivalent to 4 mm. Answer. See, you don't require to increase 3-4 more steps. You don't require this. You guys can get the answer here directly. You have just written the formula. If you are confident about your physics concept, put the value. Young's modulus, where is Young's modulus? This is Young's modulus. Put the values here, direct only, right? This is equal to, this is what? Stress, which is given to you. Stress is given to you. This, put their values. And L is 1 meter and this is delta L. Now, cancel here, come on, cancel here. And this will cancel here. 10 to power minus 3. So what will be delta? Delta will be 4 into 10 to power minus 3. Look, you have got the answer. I cannot make any shortcut thing except this. This is the shortest way. Yes, we are solving. I think, Arif, clear? Is it clear to you? Shazia, is it clear to you? Is it clear to you, Shazia? Is it clear to everyone? So if you are ultra pro, if your mathematical calculation is fast, you don't require to increase 4 more steps. You don't need to go to such calculation. Just go and get the answer in shortcut way. Is it clear, Shazia? Everyone? Okay, so a lot of students are saying for lunch break, so I'm giving you guys here just 5-minute candy break. Okay, please go and come faster, because still we have a lot of questions to do. Question number 5 from Neet 2015, question number 22 graphical question, question number 21, oh my god, so quality questions are I have brought up here. So go and have some snakes breakfast, and don't take heavy breakfast, just go and have a light breakfast, have some water and come fast. I'm waiting for you all. Okay Bhumi, okay Dikshita, just 5-minute break, everyone please come fast. Hello everyone, hi to all champions. I hope now you all are feeling energetic because you all have done with your lunch. Sir, please come to the class, continue the class. Yes, so finally the break is over. Let's begin. So, sir. I'm here, buddy, I'm here, champions. Arif. Hello, sir. Hi. Okay. Yes, join fast. Come on, everyone. Just wait a little while. 1 minute for other students so that they can join. They may join, and we can start the session again with the same zeal, same passion, same energy, everyone. Okay. Hello, Arif. Yes, Arif. Hi. Hello, sir. Hi. Varala Lakshmi. How are you, champion? Sir, thank you, sir, to come the class. I am always for you, everyone. Come on, you don't need to say thanks to me. This is my responsibility to stand firmly with you all till your NEET exam, till 2nd May. I will be strongly standing with you, besides you, everyone. Yes, join fast. Come on, I'm waiting for everyone. Fine, sir. How are you, sir? Virala Lakshmi, I'm absolutely fine. What about you? How are you all? Because now you all are close to your exam. Only few days are left. I know what kind of mindset you might have and what kind of, it's a lot of question and challenging thing may be shuffling in your mind. I know you all are so scared about your exam and all. It happens. Okay. So, lot of questions. Yeah, hi sir, I'm big fan, sir. Arif, thank you so much, Arif, sir, for these kind words. Thank you, Arif. Thank you so much, so much. I'm waiting for others. Sir, continue class. Yes, Virala, just a second for that the other student may join. Join fast, everyone. We are supposed to start the class. Hello, sir. Hi, Pooja. Okay, let's move. I hope this question is clear to you all. Everyone, tell me honestly. Yes, sir. This question. Yes. Some student was writing there when we went for lunch, actually. Some student were writing, sir, this is not breakfast time. I know, buddy, yaar. Sometime it happens. Just slip of tongue. Yeah. Okay. It's mine. Who is this? It's mine. What you are talking about, Tarun? Are you okay, Tarun? Okay. Let's move to the question number 6. What is this? Okay, from NEET 2015. My dear champion, this question is from NEET 2015. Okay, so look at the question. The question is the volume of coefficient of volume, the value of coefficient of volume expansion of glycerin is this. So, my dear champion, here in this question, the coefficient of volume expansion is given to you. Do you know? This is the coefficient of volume expansion. Generally, we use gamma. Okay, and this is given to you here 5 into 10 to power minus 4 Kelvin inverse. Okay, the fractional change, again the fractional change term came here. Do you know fractional change? So fractional change is what, my dear champion? See, my dear champion, whenever this type of terms comes up in your question, fractional change in radius, fractional change in something. So my dear champion, let me write here fractional change in what? Density. It means that frictional change in density, it means that change in density, it means that if I'm taking here this rho sign for the density here, so change in density divided by original density, this is the question. And we can also write this format as final density minus initial density and divided by this initial density. This is the question. And do you know, if we increase the temperature, the volume increases. This is just for your information, the volume increases. And do you know, density is equal to mass per unit volume. So if the temperature is increasing, the volume will be increased, but the density will decrease. Always keep it in mind. With the increment of temperature, density decreases, and that is the why final density will be smaller and the initial density will be the larger. That's the reason why it always comes up negative. We can mark their negative sign. Why? Because the temperature is increasing. You can see here, for a rise of 40 degrees centigrade from 0 to 40 degree, it means volume will be increased, but the density will be decreased. So we have a very classic formula. This density, final density is equal to initial density, which is called rho naught, we can say, and initial density here also we can write rho naught, because initial density at room temperature, rho naught. Okay, and this is also rho naught is equal to 1 minus gamma delta t. This is the formula here, 1 minus gamma delta t. My dear champion, all KCET and Neet aspirants, please keep this formula in you. And if you don't want to write here this F, you can remove F also. This is final density, and rho naught, it means initial density at 0 temperature, you can remove. Don't make the format complex. Okay, so this is all about. Now modify this, because we want the value of this whole function. So modify this format. So we can modify, we can write here, this format can be written as rho is equal to, can we please open the bracket, rho naught, and this is minus rho naught gamma delta t. Is it clear to all? Okay, so this will come here, this will come here, this will come here. So do one thing, rho naught gamma delta t can be written as rho naught minus rho. And you all know the density at 0 degree temperature will be higher, and the density at temperature something apart from 0 at any temperature, if the temperature is rising, this will be greater. So this is gamma delta t will be equal to naught minus rho divided by rho naught. This is clear. If you are writing this format in this form, so you have to put here negative sign, here negative. And if you don't want to write negative sign there, you can make this format rho naught minus rho divided by rho naught. Why? Because the density at room temperature, density at 0 degrees centigrade will always be greater than the density at 40 degrees centigrade. So this is the format here. So this format is basically fractional change in density. Fractional change in density. And do you know, the fractional change in density is equal to gamma delta t. Can we please multiply? So gamma is given here, this is the gamma. So this is 5 into 10 to power minus 4 into delta t. Delta t is equal to, this is 40 degrees centigrade, right? But here, do you know, this is in centigrade, champion, but gamma is given in Kelvin. Temperature is in centigrade, but the gamma is having unit of Kelvin. So you have to convert this 40 degrees centigrade into Kelvin, but toppers don't require to change that centigrade into Kelvin, because they know the basic of temperature, and the basic of temperature is the degree centigrade, the value of degree centigrade and Kelvin both equal at which temperature? Do you know, my dear champion? Tell me, at which temperature they both will be equal to each other? If you know, you can solve this question. There is nothing challenging. So tell me which option will be correct. This is for you, everyone. Tell me which option will be correct here. I'm waiting for the response. Let me check the chat section. Okay, a lot of students are watching. Yes, solve this question. Yes. My dear champion, please focus on questions. Please, very important question for KCET as well as for your NEET exam. Yes, everyone. Who is this? Yes. Now I want to see if the response from you all. 40 degrees centigrade value is given there. 40 degrees centigrade. Yes. Hi Preet, Arif, Tarun. Everyone, please reply me. Come on. Which option will be correct? You guys are talking with each other. I think instead you should focus on question. Very important quality question that I'm giving you, everyone here. Yes, tell me which option will be correct. I have solved. I think 1 or 2 steps is just left only. Yes, tell me, my dear champion. Yes, which option will be correct? Okay, sir. Very good. Very sincere students. You all are following my instruction, everyone. Very good. Tell me which option will be correct. Still waiting. No one responded me the correct option. I have solved. There is nothing left, my dear champion. My question is just simple. This is in Kelvin and this temperature in degree centigrade. So at which temperature Kelvin and degree centigrade both remain equal? Do you know? You don't know? If you don't know, please ask me na. Yes, Dikshita, Preet, Tarun, Hari. Tell me, at which temperature degree centigrade and Kelvin both are equal? You don't know, guys, and that is the 40 degree. 40 degrees centigrade and 40 Kelvin both are equal in strength. 40 degrees centigrade and 40 Kelvin both are equivalent. So you don't require to change this magnitude of 40. 40 degrees centigrade and 40 Kelvin both are equal. So you just need to put the value here. So put here 40, and this will be what? Minus rho, this is rho T, we can say, at T temperature, and divided by rho naught. Okay, so can we multiply here? This will become 4 into this 4 into 20 into 10 to power minus 3. So this will go there. So rho naught minus rho T divided by rho naught. So this is equal to 40. 4 into 5 will be 20. So I'm writing here 20, and one more 10 will be here added. So minus 4 plus 1 will be minus 3. So this is equal to 20 by 10 to power 3, and one more 0 here. So the answer will be 0.0020. Any option is there? 0.020. This is the answer here, because this is 10 to power minus 4 and this is 40 here. So 4 into 5 will be 20, and one more 0. So this 10 will be multiplied here. So 10 to power minus 3. 10 to power minus 3 we go there. So this will become 20 divided by 10 to power this. So 1 0 will be cancelled here. So we require the answer will become 0.002. This is the answer, 0.002. I think 0.02 is there. Okay, no problem. Option D, majority is giving me option number D. Okay. Correct. Preet, Sharad, hi Sharad, Tarun, Shruti, Dikshita, option D, perfect. Majority is giving option number D. So I will also go to option number D, because I always will be with majority. Mr. Jafar, Mir Jafar, hi Mir Jafar, welcome to Diksha Karnataka channel. Good afternoon, very good afternoon, champion. Okay, should we move ahead to the next question? I hope this is clear to you all. So this is 0.20 and we are getting a 0. Can we please cross verify once again? So this is 40. So by multiplying 4 into 5, we are getting 4 5 is 20, and this 0, one more 10 is there. So this 10 will multiply here with this. So 10 to power minus 3 plus 10 to power 1, that will become 10 to power minus 3, right? So 10 to power minus 3 will go down. So 10 to power minus 3, it means that we can write, oh my god. So this is equal to here 10 to power, this is 20 already, and this is 10 to power, this is minus 3, right? So 10 to power minus 3 will become 10 to power plus 3. So we can write here 20 divided by a 1, 2, 3. Of course, 1, 0, 0 cancel. Oh, silly mistake was there. 0.02. Of course, correct. So we were adding one more 0. We were adding there one more 0. That is not correct. Yeah. Hi, sir. Good afternoon. Hi, Aftab. So 0.02. Yes, Mir Jafar, if you are KCET student and if you are writing your KCET exam on 23rd of April, just after 2 days, these questions are very important. Look, density varies with temperature in this form. So please always keep it in mind, my dear champion. If you increase the temperature, volume increases. You all know. And if the volume increases, the density will go down. Why? Because density is equal to mass upon volume. So if you are increasing the volume of glycerin we are talking about here, so the volume of glycerin will increase. But if the volume is increasing, denominator is increasing, so this whole function density will go down. So with temperature, length increases, volume increases, and area also expands, but density decreases. Please keep it in mind. Hi Chandrasekhar, hi. Hi, good afternoon, very good afternoon. So the student who all are new here, go and please press the like button and subscribe the channel first, because I will be standing formally with you all till 2nd May. I'll be coming out with live session. These are very quality questions for all the NEET students. NEET 2026 aspirants. You should see the solution of these questions. You should also try by yourself also. Very important question. Pallavi. Hi Pallavi. Hi. Hi Preet, is it clear to you all for NEET aspirants 2026? Okay, moving to next. Okay, a spherical ball is dropped in a long column of a highly viscous liquid. Okay, the curve in the graph shown which represents the speed of the ball as a function of time. Very easy question. Okay, I think you all should focus. If you are not solving by your own, if you are not sitting here with your notebook and pen, you guys can see the screen, the way I am solving the question. And this is enough for you. And this revision class is very powerful for you, let me tell you everyone. Okay, so look at the question. So basically the question is, there is a column here, cylindrical or rectangular, let's say there is a spherical ball and long column of a high viscous liquid. So this is a liquid here filled, and this is a high viscous liquid. You know viscous liquid means the liquid having high coefficient of viscosity. It means if you drop anything, there will be viscous drag. It means the liquid, the fluid will be opposing the motion. If we compare water and honey, so honey is more viscous than water, because the atomic particles, the molecule of the honey is tightly packed with each other. So comparatively to water, honey is more viscous than water. So if you drop a ball in water and honey simultaneously, the ball which is dropped in water will go speedily, but the ball which is dropped inside the honey will be having lot of resistance force will be there. It means the opposition force will be acting by the fluid molecule in upward direction, which will be resisting the motion of the ball in downward direction. I hope you are getting my point. So this question is, if we drop, there is a ball here, and this is what, my dear champion? Highly viscous what liquid? Highly viscous liquid. It means that its coefficient of viscosity is so high, and the coefficient of viscosity is high. It means that the viscous force 6 pi eta Rv will be higher, because the viscous force directly proportional on coefficient of viscosity, and viscous force always acts in upward direction. So when you throw the ball, when you drop the ball in the viscous liquid, the ball initially having very greater speed. As the ball enters in the liquid, the speed suddenly increases, but after some time, due to this viscous drag, basically viscous drag is just, you know, like friction force. When two objects partially kept with each other, when you slide one object which is kept on the table, there is a frictional force. So viscous force is the same, which is acting in the liquid. So basically viscous force we can also say drag. Viscous drag acts in opposite direction of the motion of the ball. The ball is about to go in downward direction. It is supposed to go in downward direction, but the viscous drag is opposing the motion, and after some time the ball will start moving down with constant velocity, constant speed, and this constant speed is called terminal velocity, terminal speed. I hope you all know terminal speed, or we can say terminal velocity, because there is a direction as well. So terminal velocity, and we have a formula for terminal velocity. So when you drop a ball in a liquid, the speed suddenly increases, but after some time, because of the impact of viscous drag, the ball start going down with constant speed. It means that which graph is representing the correct format? I think this graph, because listen here, the speed is increasing, and after some time the speed has become constant. Time is increasing, but the speed has become constant. So option number B is correctly representing the motion of the ball when the ball is dropped inside the liquid. I hope this is clear to you all. Okay, yes, very long quote. Who is this? Preet. Okay, I hope this is clear to you all, everyone. So did you understand the situation? Have you understand now? Clarity is there. Now your concept is clear. This is called viscous force, which is acting in the opposite direction. Sir, it's KCET or Neet class. Pallavi, these questions are very common for both the exams, Neet and KCET, both, my dear champion. These are these are not JE type questions. JE is having some different kind of standard, but you know, the question that comes up in Neet and you know, KCET, they are little bit, at some extent they are relatable with each other, so you should follow these questions. Is it clear, everyone? Please tell me honestly, everyone, you all are enjoying the session? Your doubt is clear? Viscous force always acts in upward direction. This is clear to you all? Please tell me, everyone. Champion, show me your involvement, give me some hearts, send me thumbs up, and you all are really enjoying the session. Yes, Dikshita, Preet, Love, Pallavi, Tarun, show me your involvement. Come on, yaar. I need to see that you all are awake there. You all are doing something with me, along with me, guys. You are not sitting here in just for formality. You all are solving and trying little bit. Okay, thank you so much, Preet. Thank you so much, Love. Super. Very good, very good. And the student who have not pressed the like button yet of this live class, go and hit the like button, and don't forget to share this live session with your friends as well. And if you all are looking a channel that may ensure you to give shortcut revision, very quality and very short revision in very little time, so this is the right place. You all are the lucky charms. You all are at the right position, right place, my dear champion, because my intention is to give you a lot of things in very little time. This is my intention, and these questions are such type of question that will give you, genuinely help you out in your exam. Thank you so much, Preet, Mirza, Dikshita, Pallavi. Thank you so much, everyone. Okay, moving to next question, question number 8. Okay, the velocity of a small ball of mass capital M and density small d when dropped in a container filled with glycerin becomes constant. Again, same topic, same thing. This question is a bit linked with this topic. Okay, glycerin become constant after some time. So you know, when we put anything inside the liquid, after some time the velocity become constant, and that constant velocity is called terminal velocity. Perfect. Constant. If the density of the glycerin, it means the fluid in which we are putting the ball is glycerin and it is having density d/2, then viscous force acting on the ball will be what? Wow. So I have just told you about this term, viscous force. Now in this question we have to find out, and this is from Neet 2021, and very important for KCET exam also. Neet 2020. Mr. Sashank is giving option number B is correct. Shardan is writing option B. Someone is writing option. Sashank is writing A, B, C. What, Sashank? All options are correct. How is it possible? Are you a bhoot? Or you are having some other physics book? Okay, Ajmal is saying, okay, thank you so much, Ajma. Yes. Come on, very easy question. Come on, let me give you the clarity and concept of this question. Champion, listen. Basically, here there is a vessel. Let's say this is the vessel here, and glycerin is filled here. Glycerin fluid. This is the glycerin filled here. Okay. This is the glycerin filled here. Now, the velocity of a ball of mass m and density d when dropped in a container filled with glycerin becomes constant. It means that the viscous force has already came in contact. There is effect of viscous force because the velocity of the ball which is dropped in the liquid is become constant. Right, has become constant. It means that viscous force is acting, and if the viscous force is acting, let's say ball is here. This is the ball here, my dear champion. So do you know when we drop anything inside the fluid liquid, the weight of the body goes in downward direction. This is equal to mg, but here the capital mass is the mass of the ball, so we can write capital mg. I hope this is clear to you. This is the weight of the object which is always acts in the vertically downward direction. But two very important things: when we put a ball in the liquid, there are two types of force which acts in the opposite direction of the motion. It means there are two forces which acts in the upward direction, and the first force is viscous force Fv, and the second force which acts in the upward direction is called buoyant force. Yes, my dear champion, please keep it in mind. Two force acts in upward direction and only one force in the form of weight which is acting in the downward direction. So can we please write the formula for all these? So do you know, my dear champion, viscous force, you all know viscous force is basically equal to 6 pi eta RV, but we have to find out here viscous force, don't worry. So just write viscous force in words, because we are having the options in the terms of mg. Okay, and this is the buoyant force. This is the buoyant force, and there is formula for buoyant force. Do you know the formula? Buoyant force is equal to, the weight of the liquid displaced by the body. The weight of the liquid displaced by the body. And for buoyant force, there is a formula is equal to density of liquid, density of fluid. So I am writing a density of liquid into volume of the object. Come on, please focus on buoyant force. When we write the formula for buoyant force, we take density of liquid, not object. Density of liquid, not object, but volume of the object. Volume of the object. Please look at the formula the way I am writing. So rho Vg is the formula. This is also weight of liquid displaced by the body, and weight, weight is equal to mg, right, my dear champion? Weight is equal to mg, and mg is equal to what, my dear champion? Density into volume. Density into volume. But we are writing this weight for buoyant force, weight of the liquid displaced. The liquid at this position has displaced by this body. So that is so density, we take density of liquid, but we take density of object into g. This is the buoyant force, and that formula is there. Rho L V naught into G, V O, basically that is O into G, right? And weight is equal to, of course, this is equal to mg. So m is means what? M is mass, and mass can be written as density into volume, because we all know volume density is equal to mass upon volume. So mass can be written as density into volume, but we are writing here for this weight. So density of object will be taken as density of object into volume of object, right, into g. This is the difference, my dear champion. So we have all three. Now two forces are acting in upward direction, one is in downward direction, so we can write Fv plus Fb is equal to mg. So now viscous force we don't know, but we have Vb, Fb is equal to rho L, density of liquid, into volume of object into g is equal to mg. Mg is equal to density of object, volume of object into g. Now can we put the values here? Go. We can write here viscous force alone. So Fv will be equal to rho v rho v into v naught g minus rho l v naught into g. What we can take common here, champions? We can take here common. I think v naught can be taken as common and g. So we are having rho naught, and rho naught is the density of object, which is a small d. So a small d minus rho L is the density of liquid. It means fluid, which is d by 2. So we can write here d by 2. Can we please solve this? So if v is equal to v naught g, and d minus d by 2 will be of course d by 2, and this is equal to fv. Can you please look at here? Volume into density, volume into density, and do you know volume into density is still mass? So this is capital M, because we are taking here volume of object and density of the object. So mg divided by 2. This is the viscous force. Any option is there? Option number 2 will be the correct. Very important. Yes, is it clear to all? So when we put any object in the liquid, there are 3 types of forces acting on the object. 2 forces in upward direction and 1 force in the downward direction. The force which is acting in the downward direction is the weight. This is the weight. And the force, 2 forces that is acting in the upward direction. One is viscous force. This is viscous force. Viscous force, and this force is buoyant force. Buoyant force. My dear champion, please keep this formula in mind. Okay, yeah. So someone is writing Geeta Bore. Oh Geeta, number not matters for me. If only one student is here, I can teach them, teach him or her perfectly. This is the responsibility of a real teacher. Numbers never matter. If that only one individual become topper, that is a big reward for me. So don't see the numbers, my dear champion. Please come on. The way I'm solving the question, look at the solution. You should focus on the screen here instead of writing such things. I think you should focus on the quality, not quantity, right? So quality always dominant over quantity. So my dear champion, this is the all about solution. I hope this question is clear to you, everyone. Yes, Sharadan, very good. Is it clear to all? Option C, someone was writing option number C. No, option number C will not be correct here. Option number B will be correct, mg by 2. Because see, this is the volume of the object into density of the object. So volume into density will itself will be mass. So we have replaced. Clear, everyone? Can you explain once? Sure. So my dear, look, here in this question, there is a fluid which is glycerin, and a ball is dropped in the liquid, and we have to find out the viscous force, right? So when we drop a ball inside the fluid, there are 3 types of forces acts. 2 in the upward direction and 1 is in the downward direction. And 2 forces which acting in upward direction are viscous and buoyant force. So the sum of viscous force and buoyant force will be equal to weight. So viscous force can be written as what? Buoyant force, the formula of buoyant force is this. Buoyant force is the weight of the liquid displaced by the object. So when we find out the buoyant force, weight of the liquid displaced by the object. But this mg, a weight means mg, this mg is not direct this mg, no. In finding out the mg here for buoyant force, we use the formula of density into volume, but always take the density of liquid. So buoyant force is the weight of the liquid displaced by the body. See, just imagine this ball is not here. So if the ball is not here, so there were a lot of water molecules. Water molecule atom will be there, but when the ball went inside the liquid, inside this glycerin molecule, so the glycerin particles have displaced. So all the glycerin displaced here, the weight of all those glycerin particles, weight of that liquid, that fluid is equal to buoyant force. So always take the liquid, density of liquid into volume of the object into G. So this is the buoyant force. By putting all the values, we got the answer. Is it clear, Ambria? Ambria, I have just explained because of your request here. I hope now clear. This is clear to you. So my dear champion, keep one thing in mind, please. Listen here. Listen here. For buoyant force, we take density of fluid. Please keep this right in your notebook. We take density of fluid, right? But for weight of the object which is acting in downward direction, weight of the object, we take density of object itself. This is the difference, and everything will remain same. This is also weight. Buoyant forces means weight, so the formula of weight is equal to what? mg, and m can be written as density into volume. So this rho vg will be used here also, and for weight also rho vg. But the difference is, here in this formula density of liquid is taken, and here in this formula density of object is taken, and rest everything will remain same. Vg, volume of object, acceleration due to gravity, This is the difference, weight of liquid and weight of object. Is it clear to all? So to find out the buoyant force, we consider density of the liquid, and to find out the weight, we consider density of that object. Yes, Ambreya, is it clear to you? Tarun, Shardan? Okay, moving to next question. What is this? A wire of length capital L, area of cross section A is hanging, okay, from a fixed support. The length of the wire changes to, very easy question, and this is from Neet 2020. Yes. Okay, let's solve the question. Who is this? Tarun. Okay, let's solve the question. Can anyone give me answer of this question? Can anyone give me answer of this question? Mirza, Tarun. Hi everyone. Yes, anyone is there who can solve this question well without taking any risk? Anyone is there? Let me refresh the screen here. Very easy and just formula based question. Okay, so look at the question. The question is, read the question carefully. A wire of length L, cross sectional area is hanging from a fixed support. Perfect. So let's say this is the fixed support, and there is a wire hanging. This is the wire hanging. Okay, so the length of the wire is basically capital L. Okay, cross sectional area is A here. I cannot show this, but yeah, A is there. The length of the wire changes to L1 when mass M. Okay. So after hanging some mass M to this is mass M. So this will be mg. Weight will be mg, and weight is nothing. Weight is basically equal to force, and initially the wire was here, but now the length has increased by what, my dear champion? L1. So what will be the expression for Young's modulus? Very easy question, my dear. If this was the initial length and this is the final length, so what is delta L here? So if we talk about delta L, so delta L1 will be L1 minus L, right? Now if we talk about what is the stress here, so if we know stress is basically equal to force divided by area. I hope you all know this is the formula for stress. And do you know which force is acting to this wire? The weight of the object, which is increasing the length, which is making the expansion in this length, right? So this is the force, and here the force is equal to weight. So we can write here mg, and area of cross section is already given. The area of this wire, very thin area that is not visible, the area of cross section is A, so we can write here mg by A. This is the stress. Now using the formula for Young's modulus, I hope you all know formula stress divided by strain. So this is y here, this is y here, and stress is equal to mg by a, mg divided by a, and strain is equal to delta L by L, delta L by L. So L will go there, and delta L is equal to L1 minus L. So Young's modulus is equal to mg L divided by a into L1 minus L. This is the answer. Can you please search out the options? mg L divided by L, this is the option. Option number D will be the correct answer. Just concept, only concept. If you know the concept of Young's modulus, you can solve. Wait, sir. Tarun is saying wait, sir. Okay, Mirja, is it clear? Everyone? D. Tarun has said option D. Tarun has said option D. Shiva. Yes, option D. Mirja is saying option D. I will also go to majority with majority. Yes, option D is correct, everyone. mg L divided by A. Do you know this is the formula? Young's modulus is equal to stress by strain, and stress is equal to what? Force upon area, and strain is equal to delta L by L. So you can also go in detailed manner. Fa, stress, so force is mg divided by A divided by delta L. Delta L is equal to L1 minus L. L1 minus L divided by original length was L. Now just modify this. So mg L will go there, A will multiply with this. So L A into L1 minus L. Again same answer we are getting here. Clear to all, everyone? Clear to all, champions? Moving to next question, question number 10. Okay, liquid oxygen at 50 Kelvin is heated to 300 Kelvin. Okay, at constant pressure of 1 atm, the rate of heating is constant. Which of the following graphs represents the variation of temperature with time? So here in this question, there is a liquid oxygen, and liquid oxygen was initially at 50 Kelvin temperature. Now that liquid oxygen is heated up to 300 Kelvin, means we are directly increasing the temperature. So what will happen? Initially liquid oxygen is there. So what will happen? The liquid, when you are increasing gradually the temperature of the liquid, so the temperature of liquid increasing, specific heat capacity, temperature increasing, and after some time reaching to that spot, that maximum value, the liquid phase will change into gaseous phase. And in gaseous phase, again, still you are gradually increasing the temperature. So the temperature of gas will be increasing, and the peak will come. So in the same phase, when you are increasing the temperature of liquid oxygen, the graph will be straight. But in liquid phase, after liquid, gaseous phase has reached. So in gaseous phase, the temperature will be remain constant for a while, and suddenly the temperature will increase when the phase will change, when the phase of the liquid will change from gas to another thing. So basically here, this graph is representing the situation well. See, my dear champion, liquid oxygen was initially 50 Kelvin. It means there is some temperature. Temperature is not zero. So graph is starting from here. Graph is starting from here, not here. So this is the here. Now, when you are increasing the temperature of liquid oxygen, so temperature is increasing, and as the liquid phase change into gaseous phase, now the temperature will become, for a short period of time, will become constant. Right? And here again the temperature will increase when the liquid has changed into gaseous form, and you are increasing the temperature of gaseous molecule. There will be, Brownian motion, kinetic energy will be gaseous particle, the heat will be increasing, and after some time the molecule will be separating from each other fully. Right? So this is the graph which is representing the situation very well. Option number A will be correct here. Option number A will be correct here. I hope this is clear to you all. Everyone, tell me. Yes, Tarun? Tarun, is it clear to all? So, option number A is representing the situation well. Is it clear, Dikshita? Is it clear to you all, everyone? Shiva? Okay, moving to next question. If the temperature of the sun is doubled, the rate of energy received on the earth will be increased by a factor. This question is directly based on formula. If you know the Stephen's law, Stephen's and Boltzmann's law, you know, when we talk about the energy from black body radiation, energy, energy receiving in the form of radiation and all. So there is Stephen's law. So if we talk about Stephen's law, so according to Stephen's law, my dear champion, the energy received on the earth, or the energy due to change in temperature due to radiation, is directly proportional to temperature to power 4. This is the formula. Energy depends on temperature, absolute temperature, but the power is 4. Now look at the question. If the temperature of the sun is doubled, so if the temperature of the sun is doubled, it means 2t to power 4. So how the energy will be changed? By what factor? So E dash directly proportional to 2t power 4. So we can write here E dash directly proportional to 2 to power 4 will be 16 t to power 4. And t to power 4 is basically initial energy. So E dash is proportional to 16E. It means that, my dear champion, the energy will be increased by 16 times. Option number D will be correct. Is it clear to all? Hi Salma. Salma, yes. Ramesh, is it clear to you? Ambreya, is it clear to you all? So just using Stephen's law, we can find out the answer. According to Stephen's law, energy is directly proportional to T to power 4, right? So if the temperature of the sun is doubled, so energy which is receiving on the earth will be increased by 16 times. So just by increasing the energy by twice, the energy, thus just by increasing the temperature by twice, the energy will be increased by 16 times. Is it clear? Yes, Anaya, perfect. Ananya, D is correct answer, 16, yes. And this is from Neet 1993 question paper. So for KCET exam, very important. For KCET also, very important formula. Moving to next. A cup of coffee cools from 90 degrees centigrade to 80 degrees centigrade in T minutes when the room temperature is 20 degrees centigrade. Okay. The time taken by a similar cup of coffee means the material is same, everything is same, similar cup of coffee. Similar cup of coffee to cool from 80 degrees centigrade to 60 degrees centigrade at a room temperature. Okay, at 20 degrees centigrade is what? So there are two situations, but the material is same. Coffee cup is same. Okay, so do you know Newton's law of cooling? This question, we can solve this question by using Newton's law of cooling. There is a formula of Newton's law of cooling. If you know the formula, you guys can solve this question easily. So please try this question. I'm waiting. Yes, which option will be correct? Newton's law of cooling. Yes, Salma, Tarun, Mirza, Faizan. Yes, very good. Everyone, please give me which option will be correct here. Tell me. I'm waiting here. If you know Newton laws of cooling, you guys can solve this question easily. There is a direct formula, which is Newton laws of cooling, and there is nothing special. The formula based. 12 degree. Ramesh is writing 12. Okay. Okay. Mirza is giving me thumbs up but not answer. Tarun, which option will be correct? 12.0. There is no option like this. Options are all the options are in the form of small t. Do you know the formula? If you know the formula, you guys can solve the question here. Newton's law of cooling. I have already given you a hint. Now you can solve. C. Okay. 12C you are writing. Sorry. Ramesh. 12C. C means 13.5 T. Okay. Okay. Sanket. Hi Sanket. Sanket is also writing option number C. Let me keep a bit aside here. Okay. I think option should be visible to you all. Okay. Yes. So most of the students are writing option number C. Okay. Tarun is saying option number B, I think. So Tarun, you are not sure about the formula. Newton's law of cooling. Try it. Come on, try it. You all can solve the question. See, you all can solve this question just based on Newton's law of cooling. Very important formula. Very important formula. Newton's law of cooling. Option number D. Dikshita is saying option number D will be the correct. Okay, just wait a little while, Dikshita, please. So for your comfortability, I'm giving you formula also. Now you all can solve the question here. If I'll be giving you the formula. Okay, so the formula is, according to Newton's law of cooling, rate of cooling. So rate of cooling means what? dq by dt. Rate means we have to divide that parameter by time. That's why we are writing d cooling, rate of cooling. So is equal to K into initial temperature plus final temperature divided by 2, average of initial and final temperature. Average of initial and final temperature minus room temperature, T naught. This is the formula of Newton's law of cooling. Please, my dear champion, focus here. This is the formula for Newton's law of cooling. Now read the question carefully. Now read the, I've given you the formula. Now you all can solve the question. Now read the question carefully and give me the answer, please. It's like birds are always fly. Who is bird here? Are you talking about me? Okay, I used to move here and there quickly, frequently. That's why you're saying. Okay, yes, Dikshita, Tarun. Come on, yaar, you all can find the answer here. So basically, a small t, you might be confused here. Instead of writing small t, I think you should write capital T, because small t sometimes represents time. So capital T will make sure we are talking about temperature. Okay. So you have formula. Oh, this is dq. What we have written here? Okay, this is Newton's law of cooling, my dear champion. So let's talk about here. This is dt, change in temperature. This is not dq. Change in heat. This is not change in heat. This is change in temperature, because Newton's law of cooling here. So dt is the change in temperature. Come on, dt is the, my dear, dt is the change in temperature, means T final minus T initial, right? So what will be dt here? So dt, for this formula we can modify Tf minus T initial divided by dt, and dt can also be written as small t, because initially temperature was initially the body was at 0 degrees, so we can write direct T1 minus T minus 0, so this is equal to small t, right? And now the formula has become T initial plus T final divided by 2 minus T naught. So this is the final formula, my dear, for Newton's law of cooling. Now apply the formula for both the situation. So if we apply the formula here for both the situation, 90 degrees centigrade and 80 degrees centigrade. So a cup of coffee cooled from 90 degree to 80 degree. 90 degree to 80 degree. So what will be the dt here? Sir, solve please, we want answer, sir. Yes, Ramesh, I am solving. I want to see the answers from you. That's why I was waiting for you, everyone. That was the intention. That's why I was waiting for you, everyone. Sir, like but Tarun is saying option number B, we have more curiosity. Oh, you are talking about curiosity. Okay, so if we put the values here, so can you see here, my dear champion, this will be change in temperature, dt, 90 degree to 80 degree. So the change in temperature will be 10 divided by small t is equal to k, we don't know k into, this is ti plus tf, means 90 plus 80. 90 plus 80 divided by 2 minus T naught is the room temperature. This, my dear, this is room temperature. Room temperature. So can we put here room temperature, which is equal to 20. So solve this. So by solving this, we can get the value of k. So this is k, and this is 90 plus 80. 90 plus 80 is 170, and 170 divided by 2. I think this will be 85. Right, my dear champion? And minus 20. So k will be equal to 10 divided by t into 85 minus 20. This will be 65. So can we cancel this? 2 5 are 10, and this is 13 5 is 65. right? So this is K we have is equal to 2 by 13 T. This is the equation number 1. We can keep this as equation number 1. Why? Because it will be helping a lot. 2 5 are 10 and 3 5 are 65. I hope this is clear to you all. Yes, any confusion to anyone till here? Yes, Tarun, any confusion to anyone? Is it clear to all? 2 by 13, 2 5 are 10 and 13 5 are 65. Now this is the first equation. By using the first situation, we got the value of K, and this K is required for the second situation. Now come to second situation. Now in second situation, the time taken by the similar cup, we have to find out this time, we don't know. So can we use this formula? So what is the difference in the temperature? 60, so the difference will be 20 divided by T, we don't know, so we can write T dash is equal to K and under bracket average of these two temperatures. So 80 plus 60 is 140 and 140 divided by 2 will be 70. 70 minus T naught is equal to room temperature, which is again 20. Okay, so 20 by T dash is equal to K into 70 minus this will be 50, and we have K is equal to here, so we can put that. So 20 divided by T dash is equal to K is equal to 2 by 13 and into 50 here. So can we please solve this? So T dash will be equal to I think 20 into 13 divided by 100. So my dear champion, 100 and small t is also there, so small t will come there, right? So 20 will cancel by 5 times, so T dash is equal to 13 T by 5, my dear champion. Any option is there? Can you please check the option? 13 T by 5, which is equal to C. So this is all about the answer. Yes, Ambreya, is it clear? Dikshita, Tarun, is it clear to you all how I have solved this question? So according to Newton law of cooling, just using this formula, this is change in temperature. So change in temperature, 90-80, the change in temperature will be 10, and here 80-60, the change in temperature will be 20. So by putting the value, we got the answer. Clear to you everyone? So this is Newton's law of cooling, and this question is from Neet 2021. Tell me, you all are enjoying the session? Any doubt is there? If anyone is having any kind of doubt, please let me know. Write your name here and write your problem, whatever the difficulty you are facing, please write here in chat section. Okay, moving to next question, question number 13. The quantities of heat required to raise the temperature of two solid copper spheres of radius R1 and R2, and here R1 is equal to, the relation is given, R1 is equal to 1.5 R2, so we can write here R1 divided by R2 is equal to 15 by 10. Yes, we can write here. So this is 3 5 ja 15 and 2 5 ja. So basically R1 by R2 is here 3 by 2. This is okay. So the quantities of heat required, do you know, when we talk about the quantities of heat required, so we always consider specific heat. The quantity of heat required to raise the temperature. When the minimum amount of heat required to change the state, that is latent heat. But the heat required to change the temperature, that is specific heat, and we have formula delta Q. Q is equal to, I hope you all know, ms delta T. This is the formula. ms delta T. M is the mass of the object whose temperature is increasing, S is the specific heat capacity, and delta T is the change in temperature. But here these two are constant because we are increasing the heat temperature by 1 Kelvin for both. So delta T is same, and here the quantity of heat required to raise the temperature of two solid copper sphere means the material is also same. Both are made up of same material, so S is also same. So Q here is directly proportional to mass, and do you know, my dear champion, mass is equal to density into volume, and density is also constant, so volume is equal to 4 by 3 pi r cube. So these all things are constant. It means that mass is directly proportional to r cube, and if mass is directly proportional to r cube and this amount of heat is directly proportional to m, so we can say Q is also directly proportional to r cube. This is first equation, and this is second equation. So we can write here from first and second we have this equation, Q is directly proportional to R cube. So we can modify this format, Q1 divided by Q2 is equal to R1 cube divided by R2 cube, right? So Q1 divided by Q2 is equal to here R1 divided by R2 whole cube. Now we have formula here. We have to find out the ratio of quantity of heat required. So this is the answer, Q1 divided by Q2, and R1 by R2 is 3 by 2, 3 by 2 whole cube, and do you know 3 square cube will be 27 and this 2 cube will be 8. So answer is 27 root 8, 27 whole 27 ratio 8 is the answer. Option C. Lot of student is writing option number C. Why you guys are writing option number C, my dear champion? Q1 Q2 is directly proportional to R1 cube. Check it once again everyone. Lot of student is giving here option number C answer. Can we please check it again, my dear all champions? No need to worry, just check it once again everyone. Yes. Check it once again everyone. Tarun is saying option number A, sir. Okay. Option A, sir. Okay. Okay, sir. Answer, buddy, answer. Why you guys were responding option C? I couldn't understand. Mirja, Ambreya, everyone were writing option. I don't know, guys, what you all are doing here. Q1, Q2, please keep this formula in mind. My dear champion, this formula is very important. Please write in your notebook. The ratio of heat required is equal to R1 by R2 cube. And we can also write this formula in the terms of diameter. Do you know, my dear champion, diameter is equal to twice of radius. So R1 will be equal to D by 2, D1 by 2, and R2 will be equal to D2 by 2, right? So if we modify this formula, so in the terms of diameter, we can also write same. See, R1 will be replaced by D1 by 2 and D2 by 2, so D1, D2 will be cancelled here. So D1 by D2 whole square, same formula. So sometime question comes in the forms of diameter. Sir, we check and after solve question, sir. Is it clear, Ramesh? Is it clear, Tarun? Ajma? Is it clear to all, everyone? I think the student who responded as option number C, don't worry, it happens sometime. You might made any mistake somewhere, so please keep it in mind. Sir, R1 by R2 is 3 by 2, no? So you got that only. So yeah, R1 by R2 is 3 by 2. But we want to find out the ratio of heat capacity, heat required. So the ratio of heat required is equal to R1 by R2 whole cube. Ambreya, this is whole cube. So by putting here R1 by R2, which is 3 by 2, so 3 by 2 whole cube will be 27 ratio 8. Come on, champion. Is it clear, Ambreya, to you? Yeah, you are right. R1 by R2 is 3 by 2. But we need to put that value here again to find the ratio of this. To find the ratio of this, we have to put the value here. So 3 by 2 whole square will be 27 ratio 8. Is it clear, Ambreya, Ramesh, Tarun, Mirza? Clear? If everything is clear, show me your involvement. Send me some hearts. Send me, come on, everyone. Very good. Send me some thumbs up, hearts. That indicates that you all are awake and you all are enjoying the session. Ambreya, Ananya, yes sir, thank you Ananya. Is it clear? Okay, moving. So my dear champion, the main important thing is to get the formula, to keep the formula in mind. Don't stick with this question only. Stick with this formula. Just understand the worth, the importance of this formula. Because the question you might get different type of question. The question may not be exactly same. The question may be the different one. The language of question may be changed there. But this formula will help you out there. Formula is important. Thank you, Tarun. Thank you, Ambreya. Thank you, Ajuma. Thank you everyone for showing such love and appreciation here. Thank you so much. It really means a lot to me. Ramesh, thank you. Okay, moving to next question, question number 14. You don't require to solve this question because this question is just based on formula. I have taught you this formula earlier in Newton law of cooling, if you remember. Okay, the first question. So two ends of a rod of length L uniform. So basically there are two ends. This is a rod, and the two ends are having different temperature. This is T1 and this end is having T2 temperature, but T1 is greater than T2. So my dear champion, if T1 is greater than T2, so the heat will flow from T1 to T2. So what will be the rate of heat transfer? Come on yaar. The rate of heat transfer depends on thermal conductivity of this material, whether the material is of silver, copper, because in different of material, the rate of heat transfer will be different. Is that clear now? If I am having a material of 1 centimeter length of copper and silver both, so would it be the rate of flow of heat would be same in both? No, because the change in material, the rate of heat of flow will be changed. So the rate of heat transfer will depends on thermal conductivity. So okay, and this dt is directly proportional to what, my dear champion? Change in temperature, and change in temperature is equal to this T1 by T2, and this heat transfer is inversely proportional to length. Yes, if this is a large length, a very high length of rod, and I'm heating this rod, so the heat will take a lot of time to reach here. But if you heat very short rod, a piece of rod, so just after heating only 5 to 6 seconds, this end will also be heated up. So the length is higher, the heat of transfer will be lower. If the length is lower, the rate of heat transfer will be higher. So it depends inversely proportional. So if we combine all these three, and one more thing also, the heat transfer is directly proportional on area also, area of cross section. So these are the three parameters on which heat transfer depends. Now if you combine all these, if you combine, what happened? If you combine, let's ignore this, because that will, the proportional, to remove the proportional k will come. So if you combine these all, so dq by dt is proportional to k into a into T1 minus T2, just remove k because we are just considering here only A. So, and this is L. Now to remove proportional sign, we always required a constant. Now that constant K will come, which is thermal conductivity. So Ka T1 minus T2 divided by L. This is the correct answer. Any option is there? Can you please find out any option? Ka T1 minus T2 divided by L. Option number C will be correct. Let me check your response. Welcome sir. Welcome sir. Everyone. Thank you. So option C. Yes, very good yaar. Tarun is correct. Mirja is correct. Very good. Superb everyone. Superb. The way you all are solving the question, it is really appreciating. C is the correct option. Yes, of course, C is the correct option, everyone. Yes, Ananya. Yes, Ambreya. Tarun is correct here. So the student who have not subscribed the channel yet, go and hit the subscribe button. And one very important thing, the best part of this class is you all can get the solution of these questions along with the PDF, my dear. So you need to follow the channel, subscribe the channel, and you need to press the hit the like button. Go and press the like button, and the link of this PDF, lecture PDF, will be given in the description. There is a link. You just need to press the link and you can get the PDF. Okay. Okay, is it clear to all? Welcome. Moving to next question, question number 15. Heat is flowing through two cylindrical rods of the same material. The diameter of the rods are in the ratio 1:2 and the length in the ratio 2:1. Very good yaar. If the temperature difference between the ends is same, it means delta T is same, then the ratio of flow of heat, again we are talking about flow of heat, it means heat transfer. And we have formula of heat transfer. I have just written the formula just in previous slide. So dq by dt is equal to K A, and this is what, my dear champion? T1 minus T2, means change in temperature, and divided by L. So we can write this format, dq by dt as K A delta T divided by L. Now according to this question, the temperature difference between the ends is same. It means delta T is same and K is what? Heat transfer through two cylindrical rods of the same material. And if this is same material, here the word same material is coming. It means K is also same. So here in this question, dq by dt is directly proportional to A by L. This is the concept. Why? Because K and delta, here we can write we can mention the region, K and delta both are same. Constant we can write. So that's why we have ignored. Now we are talking about cylindrical rod. So do you know cylindrical rod? If there is a cylindrical rod, my dear champion, so this will be the area of cross section, which is equal to pi r square. Pi r square, right? Okay. And A is directly proportional to r square because pi is the constant. Right? Okay. Now, okay, and the length is, so A1 is proportional to R1 square and A2 will be proportional to R2 square. So can we put here, we have to find out the ratio. So just apply the formula dq1 by dt divided by, for the second rod, dq2 by, so this will become A1 by L1 divided by A2 by L2, and A1 will be replaced by R1 square by L1, and A2 will be replaced by, because that depends directly on radius whole square, so this will be R2 square divided by L2. So the formula will become R1 square into L2 divided by, this is R1 square into L2, this is R2 square into what, my dear champion? This is L1. So this is R1 by R2 whole square into L2 minus L1. Now can we put the values R1 and R2? The diameter of the rod are in the ratio. If the diameters are in the ratio of 1 by 2, so diameter is what, my dear? Radius, twice of radius. So radius will also be 1 by 2. So this is 1 by 2 whole square. And L2, this is the ratio of length. This is the ratio of the length. It means this is L1 by L2, which is 2 by 1. But we required L2 by L1. But we required L2 by L1. So L2 by L1 will become 1 by 2. So we can put here 1 by 2. So can we please solve this? 1 by 2 whole square will be 1 by 4 into 1 by 2. So this is equal to 1:8. Any option is there? Option number D will be the correct answer. Very good question. 15D. Oh, perfect, yaar. Superb. Ramesh is correct. Tarun is correct. Mirza is correct. And Ambreya is still about to respond. Sir, how many digits is your salary? What a question. The salary that I'm getting is enough for my living, standard of living, to maintain everything, to live a very peaceful and happy life, to fulfill all the requirements of my family, of my mother, of my sister, and everything. That is enough for me. Yeah, I'm getting good. Thank you so much. Okay, so I hope this question is clear to you. So look, the way, see, according to the need, according to the requirement, I have modified the question in that format. So here in this question, the ratio of length is given and the radius is given. And how we can bring the radius into the frame? By mentioning the area, because area is the term which is having radius, area of cross section. That is the why we have focused on area also, so that we can bring radius into the frame. How sweet of you all, everyone. Okay, should I move ahead to the next question? Question number 16, guys. Enjoying the session? Enjoying the session, everyone? Please tell me honestly if you all are enjoying the session. Tell me honestly. Yes, sir, we are enjoying the session and we have subscribed the channel as well, and we have pressed the like button also. Okay. Yes. Thank you, Tarun. Thank you so much, Tarun. Yes. Yes, sir. Ambreya. Thank you, Ambreya. Tarun. Very good. Ramesh. Thank you, sir. Ajma. Yes, sir. Very good, Ajma. So how many of you is dreaming for Ramaiah College for your next phase of your degree, to get the degree from such college, RV College, PACE, AIMS Delhi, Maulana Azad Medical College, Vardhaman, Mahavir, Delhi, Lady Harding College. So how many of you are dreaming to get into such colleges, everyone? Ramesh is writing something in, it's Kannada, right? Very good. Yes, Tarun. Okay. Should we move ahead to the next question? Question number 16 for you all. Okay. Look at the question. Not decided, sir. Oh, come on, decide, yaar. Okay, now you're not looking at any colleges further, but you are dedicated to get the good rank, and this is the identity of a good student. If you are dedicatedly preparing to get double-digit rank, so the college you will automatically get that college. So that's very good, sure, sir. Okay. So this is very crucial phase. This is very sensitive phase that you all are in. For KCET aspirants, only 2 days are left. For NEET aspirants, almost, I think today is 20, almost 12 or 13 days are left. So my dear champions, stay very positive, calm, confident. SBR Degree College. Okay, Ambreya is writing SBR Degree College. Okay, so look at the question. Given below are two statements. You know, my dear champion, for all NEET aspirants, this year you might get question of assertion and reason based also in question paper. So this is very important to focus such questions as well. So I have brought up this question PYQ of assertion reason. So there are two statements given. One is assertion and other is reason. Look at the first. Assertion says that houses made of concrete roofs overlaid with foam keep the room hotter during summer. What they are talking about? So the concrete roof is there, but that is overlaid with foam, which keep the room hotter. Foam keeps the room hotter? What this is? Foam keeps the room colder, because foam is having, you know, so many inside the foam is having so many air pockets which absorb the heat. So foam packets not keep the room hotter, it's keep the room colder. It maintain the temperature because it absorb the temperature, it absorb the heat energy. So the question is saying if the concrete roof is overlaid with foam, it keep the room hotter. This is wrong. Assertion is absolutely false. And look at the reason. The layer of foam is insulation, prohibits heat transfer. It never allows heat to transfer from it. Why? Because it contains air pockets. Yes, in foam, you can see foam. In foam, there are a lot of small, you know, air pockets are there. And what is the work of the air pockets? Air pockets not allow to pass air from itself. It prohibits the entering of the air. So basically, in the light of the above statement, choose the correct. Basically, our form assertion is definitely false, and this is definitely true. So A is false and reason is true. Option number B. I will go to option number B. Yes. Is it clear to all? Yes. B is Tarun. B is correct. Yeah. Moving to next question. Question number 17. Oh my God. This is oh my God question. Can you see the question, guys? This is from NEET 2016. Very important question. Three liquids of densities rho 1, rho 2, that is given in the form of P. Okay, no need to worry. P1, P2, P3 with P1 is greater than P2 is greater than P3, having the same value of surface tension T, rise to the same height in three identical capillaries. So my dear champion, this is very important question, I can say, and here in this question we are talking about capillaries. So when we fill the liquid in the capillary rise up. you know, this is called capillary rise topic. I hope you have studied about this topic, capillary rise, and we have a formula also for capillary rise. Capillary rise. The angle of contacts are given theta 1, theta 2, theta 3, and 4 options are given here. I want to see the answer of this question from you all, everyone. So if you guess answer in such question, your guessing should be very smart, not random guessing. Don't follow the random guessing in exams like Neet, because there will be negative marking, right? So try to follow the elimination method. If you can go through the options, just try to eliminate one option, 2 options, so that the chances of getting the correct answer will be increased. So you guys can apply elimination method. Try to find out this question. This is from capillary rise question. Can I have water bottle? Capillary rise. Yes, which option will be correct, everyone? This is capillary rise formula. Yes. Option C, Umbrea is saying option number C. Win is saying 2 cos theta. I'm not saying what you want to say. Mirza is saying option number C. Umbrea option C. Okay. Any other one? Dikshita is saying, sir, option number C will be the correct answer. Okay. Have patience. I myself, Belgaum. Ananya is saying option number C. Very good question. Just wait little while, my dear champion. Let me see your response, and after just few seconds I'll be solving this question for you. Very easy approach. Just wait. Have patience, everyone. Okay. Now Tarun is writing option number B. Okay, so majority students are writing option number B or C. Okay. Okay. Any other one? There is no any other options except B and C. Only B and C we are getting here. Okay. So, see, my dear champion, if you know the formula, you can solve the question. There is nothing. If we talk about capillary, so you have very important formula for capillary rise due to surface tension, and that formula is equal to H is equal to 2T cos theta R rho G. I hope you all remember this formula. 2T cos theta by R rho G. T is basically surface tension. Sometimes this formula is also written as 2S cos theta. So surface tension is represented by capital T as well as capital S. So you don't need to worry about. R is what, my dear? Radius of capillary, right? And rho is the density of fluid which is filled, and G is the acceleration due to gravity. And can you please read the question? 3 liquids of densities means the liquid are same. All the liquids are same, having the same value of surface tension. It means surface tension is same, S T is same, 2 is constant, R is of course constant, and here this is rho. Rho means density, and density are different. So in this question, this 2T, let me use another color, this color, 2T, this whole family, 2T, R and G, all are constant. All are constant. So my dear champion, if all are constant, so I can say H is directly proportional to cos theta divided by rho. H is directly proportional to cos theta by rho. And can you see here, my dear champion, in this question, having the same value of surface tension, rise to the same height. Oh my God, rise to the same height. It means that H1 is equal to H2 is equal to H3. All 3 liquids. The capillary rise are same. So we can write here H is equal to cos theta by rho. So based on this information, we can write this as cos theta 1 divided by rho which is equal to P. Basically density is represented as P. So let's write here P. Cos theta divided by P1 is equal to cos theta 2 divided by P2 is equal to cos theta 3 divided by P3. And can you see one very important thing here? P1 is greater than P2 is greater than P3. So if here in this question P1 is greater than, P2 is greater than P3. So if P1 is greater, P2 is greater, and P3 is greater, it implies that, and all the families are equal to each other, it implies that it has to be greater than this and it has to be greater than this. The cos theta 1 will be greater than cos theta 2, and cos theta 2 will have to be greater than cos theta 3, because P1 and P2 and P3 are greater than, in this form, P1 is greater than P2 is greater than P3, and all the families are equal. It implies that, so it implies that cos theta 1 is greater than cos theta 2 is greater than cos theta 3. Now just look at the trigonometry. Cos theta 1 is greater than theta 2. So do you know, my dear champion, at which theta is 0 degree, so we got cos 0 is equal to 1, right? But if we got theta 2 as a 90 degree, so cos 90 is equal to 0. So my dear champion, at which angle cos is giving you greater value? At a smaller angle. At a smaller angle, cos value will be greater, and at greater angle, cos will be smaller. If I ask you, cos theta is 180 degree, so what will be cos 180? Oh my god, cos 180 will be minus 1. So as we are increasing the angle, the value of cos is decreasing. So here, the value of cos theta is greater. So what it is implying, what it is indicating? It indicates that the theta 3 will be greater. Because if we write cos 0, cos 90, cos 180, so cos 180 will be smallest one, cos 90 will be 0, and cos 0 will be 1. So it implies that theta 3 will be greater than theta 2 will be greater than theta 1. This is the answer. Any option is there? Please look at any option is there. Any option is there? Theta 3 is greater than, theta 2 is greater than theta 1, and pi by 2. This is pi here, and theta, this is pi, and range will go from pi by 2 pi. So this is the options. Check out the option. Which option will be correct, everyone? Yes, who is responding? Anyone responded any option? Option of C only, right? Good evening, sir. Hi, Bhavna. Good evening. B. You guys are writing B. Correct. Everyone, superb guys. Yes, B is correct. Very good. So where is the B? Yes, B option will be correct, because the range is from 0 to this here. Because theta can capillary rise. The theta, if we talk about theta, we cannot consider here as pi. In capillary, this is the liquid here, and this is the capillary. When we put capillary, so the liquid go in this way, and this is the theta here, contact. So this theta can go maximum 90, so 0 to pi by 2. So this option, sometime the few students might be confused here also, because this is also following theta 3, theta 2, theta 1. But theta are the angle of contacts. And angle of contacts, the range of angle of contacts will be 0 degree to 90 degree. So we cannot consider this pi. That's why this option will be cancelled here, and only this option will be correct. I hope you all have understood. Sorry, sir, I am wrong. Don't worry, Amriya, no need to worry, it happens. Yeah. Is it clear to all champions? Is it clear to everyone? Is it clear to all champion? Any problem to anyone? Please let me know. And if you all are enjoying the session, write in chat section, yes sir, we have enjoyed a lot. Very powerful session. Please write in chat section. Yes sir, we all are enjoying the session, and this is from Neet 2016. So the question was fully based on formula and little bit concept here. This was the formula for capillary rise. This is called capillary rise. Capillary rise. Tarun, yes sir. Ananya, yes sir. Very good, very good. Thank you so much for your this appreciation and love. Thank you so much, everyone. Okay. Superb. You guys are so funny. Moving to next question. Sorry, all the question we have done with today's live session. Thank you so much, everyone. Thank you so much everyone for being here. Thank you so much for being in this live session from the beginning to the end. And we have reached to question number 17. Thank you so much. And just let's wait. And after one day, yeah, at the gap of one day, I'll be coming with another live session on hopefully today's 22nd. Yeah, I'll be coming on live session and the chapter. Oh my God, the chapter will be your favorite chapter. Do you know? Do you know your favorite chapter? Which is your favorite chapter? I know, guys. Your favorite chapter is System of Particles and Rotational Motion. So I'll be coming out with the new chapter very soon, and the chapter will be of System of Particles and Rotational Motion. Some technical problem is here. Okay. Yeah, so the next session will be on System of Particles, your favorite chapter, System of Particles and Rotational Motion, in which we'll be talking about inertia, moment of inertia, okay, center of mass, torque, angular momentum, angular acceleration. So in next live class, everyone, in next live class, so don't forget to come in my next live class, because that only single live session will give you clarity of System of Particles, because I'll be coming out with a lot of quality questions, important question, and I'll not be teaching you just only solution of the question. Along with the solution, I will be explaining shortcut method, using shortcut method, a bit theoretical portion also. So apart from solution of the question, I'll be teaching you some topics, important topics also, that is very relatable for the NEET exam and as well as KCET. So I'll be catching you everyone. Thank you so much for your sir. Thank you for teaching us. Thank you so much. Bio is beautiful, but physics is powerful. No doubt, by physics is so powerful. Yeah, because it required a lot of mathematical calculation, formula, maths, approach and all. So I hope you have enjoyed the session, guys. Thank you so much. So now it's time to say bye to you all, and I'll be looking forward to catch you all in my next class. And the student who have not subscribed the channel yet, go and hit the subscribe button, share the channel with your friend, and don't forget to come in our next class. Bhavana, thank you so much for your effort, sir. Thank you. Thank you, Ambreya. Thank you so much for this kind of appreciation. It really encourages me a lot to deliver you some quality content for you everyone. And I will be standing firmly besides you everyone till your 2nd May, because 3rd May is your exam. And after exam also, the student who is looking forward to appear in NEET 2027 exam, there might be your junior also, so do share this channel with them also, because soon we are launching a series 1-year course program for NEET 2027 aspirants. So go and hit the description link. There will be link given to you. You guys can get this sheet, the solution of this lecture over there. Thank you so much. Stay blessed and take care of yourself, take care of your health, follow a good diet and follow your parents as well. Thank you so much. Bye bye everyone.